Today we're going to talk about oxidation states of carbon, but first we need to review something from Yankin. What is oxidation and what is reduction? So a few concepts first. And so let's say in general when we talk about oxidation states, there are a few rules that we learn in Gen Chem. And so for example, for elements, say that we have elements, so just say this, right? Oxidation state we say is 0. Also for ions, simple ions, such as say sodium or say magnesium, here oxidation state equals the charge. So we're going to say oxidation state, same as charge. Things get more complex when we combine elements. So, and for those, we're going to do a little bit of algebra, taking into account a few rules. So hydrogen, in most compounds, we're going to say oxidation state +1. And that is except for hydrides. Those are special compounds such as NaH, in which hydrogen has a -1 oxidation state. But other than that, we're going to consider hydrogen +1. And the other element that we need to remember is oxygen. And oxygen, we're going to say in general, is -2 oxidation state, except in peroxides. And peroxides is, for example, this is hydrogen peroxide. And here oxidation state is going to be -1. But other than that, these are the rules that we in general handle. And so let's just work a few examples. And from here, from reviewing this, we're going to go into carbon oxidation states. So I am going to erase this a little bit to work with a few examples that contain more than one atom, so just not simple ions. So let's do this. I need to clean up a little bit. Okay, and so let's say that we have, I'm gonna work with a salt. Let's say that we have ammonium nitrate. The salt, we have 2 ions. We have ammonium and we have nitrate. The other thing that I mentioned besides this rules is that when we have a molecule with 0 charge, and let's say that we have this magnesium dioxide. So when we have that, the total, when we sum up, when we add the oxidation state, we need to add up to the charge of the species. And since this is a molecule, it is 0 charge. And when we do that with ions, then the sum of all the oxidation states need to give me the net charge of the ion. So here we go. We're going to try that. And this is simply doing a little algebra. So what we're doing is, in this case, for example, we said that total net charge is 0. So it's 0. It needs to add up to 0. And I know that oxidation state of oxygen is -2. And I don't know the manganese, so I'm going to say X. But I have 2 oxygens, and it's -2. And it needs to add to 0. So my oxidation state of manganese is 4. That's 4. So let's do the same here for the ammonium ion, for example. And so here I have, oh, this is ammonia, no, ammonium ion. That. Let's see what is the oxidation state here. So I say total charge of the ion is +1. But I don't know the oxidation state of nitrogen, so I'm going to say oxidation state is X. And I have 4 hydrogens, and their oxidation state is +1, as we saw, and total charge is +1. So here, the oxidation state for that math to work out, we know that this is going to be -4 + 1 is going to be -3. So let's do that for last one, for nitrate. So in nitrate, we have a net charge is -1. So we're going to take that into account. Well, I don't know the oxidation state of nitrogen, so I'm going to say X. And I have 3 oxygens. So 3 oxygens in each one. Oxidation state is -2. And everything needs to add up to 1. So here is, you have a, and this is -1. So the oxidation here is 5. So notice in the salt, we have nitrogen with 2 different oxidation states. It was -3 in ammonium ion, and it was +5 in nitrate. But how that has anything to do with organic chemistry. So in my next video, we're going to explain oxidation states in organic compounds, meaning carbon oxidation state, different carbon oxidation states.